Hello everyone, I am Mr. Ashish Chaudhary from VPM's Maharshi Parshuram College of Engineering. In our fluid mechanics lecture series, today we are going to solve problems on a viscosity measurement and the force measurement when the plate is moving into the viscous oil. Okay, so now first problem is the flat plate of an area 1.5 into 10 raised to 6 mm square is pulled with a speed of 0.4 meter per second relative to another plate located at a distance of 0.15 mm from it. Find the force and power required to maintain this speed. If the fluid separating them is having viscosity as 1 point. Okay, so now we'll solve one by one. So first we will write down the given data. So given data as area of plate A is equal to 1.5 into 10 raised to 6 mm square. We will convert it into 1.5 meter square. The speed of plate as a change in velocity, as initial velocity we will consider as zero velocity and final velocity as 0.4 meter per second. So difference in the velocity we will consider du is equal to 0.4 meter per second. Now the distance between two plates, so we will take the distance between two plates at dy is equal to 0.15 mm. This is equal to 0.15 into 10 raised to minus 3 meter, and the viscosity of oil as mu is equal to 1 poise. So we'll convert it into newtons second per meter square as 0.1 newton second per meter square. Now first we will write down the Newton's law of viscosity formula. So in that we'll write down tau is equal to mu du divided by dy. So here tau is a shear stress. Okay, so I will substitute the values as mu is equal to 0.1 newton second per meter square, dy is du is 0.4 and dy is 0.15 into 10 raised to minus 3. If we solve this we will get tau as equal to tau is equal to 0.1 into 0.4 divided by 0.2 into 10 raised to minus 3. So this is as 266.67 Newton per meter square. Okay, now to find out the force required to drag the plate. So F is equal to tau into area. So shear stress multiply with area of plate, we will find out the force. So shear stress is 266.67 into area as 1.5 meter square. So F is equal to is 400 Newton. So F force is equal to 400 Newton. Okay, now to find out the required power as P is equal to F force multiply with velocity of plate. So force is 400 Newton multiply with 0.4 velocity of the plate. So it is 160 watt. Okay, so this is our answer. So first power is 160 watt and force we have calculated as the 400 Newton. So this is our answer. Now we'll see another problem as So another problem is we have two large plane surfaces are 2.4 centimeter apart. The space between the surfaces is filled with the glycerin. What force is required to drag a very thin plate of a surface area 0.5 meter square between the two large plane surfaces at a speed of 0.6 meter per second? If we have the two conditions, the first is the thin plate is in the middle of the two plane surfaces, and second, the thin plate is at a distance of 0.8 centimeter from one of the plane surfaces. Okay, question mark. Take the dynamic viscosity of glycerin is equal to 0.10 into 10 to the minus 1 newton second per meter square. Okay, so we have drawn the figure here. We have the two plane surfaces which is having 2.4 centimeter distance apart, and in that the gap is filled with the glycerin which has viscosity 8.10 into 10 to the minus 1 newton second per meter square. And in that, at the middle of the this plane, we have provided one plate, and this plate is moving with a velocity of 0.6 meter per second. Okay, and during that this plate is having is placed at the middle of this two plane, that means 1.2 centimeter from one of the plane. So for that, for the total problem we have the given data. So total distance is y is equal to 2.4 centimeter, area of plate is 0.5 meter square, velocity of plate is 0.6 meter per second. If you consider initial velocity of plate is 0, then you will find out change in velocity as du is equal to 0.6 minus 0 is equal to 0.6 meter per second. And the viscosity of the glycerin mu is equal to 8.10 into 10 raised to minus 1 newton second per meter square. Okay, so if you will consider F1 is the drag force applied from one of the plane, and similarly F2 is drag force applied from another plane. Okay, so total drag force is F, and this is equal to F1 plus F2. But here for first condition, the distance between these planes as the same for the first case, that is the uh, plate is available at middle of the case, middle, so that's why force applied from the both side will be similar. So we will only find out the force F1 as a drag force, and we will multiply with double, we will get the total drag force. Okay, so for that we know that the Newton's law of viscosity as tau 1. So F1 is equal to tau 1 into area of plate. So for that we will find out the shear stress from the one of the plane. So tau 1 is equal to mu du by dy. So mu is 8.10 into 10 raised to minus 1 multiply with velocity change we already find out at 0.16 meter per second and 0.6 meter per second, and distance between the plate and plane is 1.2 centimeter. This is 10 raised to minus 2. Okay, so now, so tau 1 shear stress will be calculated as 8.10 into 10 raised to minus 1 multiply with 0.6 divided by 1.2 into 10 raised to minus 2. So this is as 40.5 Newton per meter square, and drag force applied by one of the plane. So F1 is equal to, we will substitute the value 40.5 into area of plate. Area of plate we have given as 0.5 meter square, as 0.5 meter square. So multiply with 0.5. So we have the answer is 20.25 Newton. So now the total drag force F is equal to F1 plus F2, because the distance, if you see in the formula for the shear stress, if you find out for second condition for the another plane, second plane F2, so in that dynamic viscosity is same, change in velocity is same, distance is again same, so that's why the value we are getting same. So that's why F1 is equal to F2. So F1 plus F2, that means 20.25 plus 20.25, we are getting answer is 40.5 Newton. So this is our answer for case first. The total drag force as 40.5 Newton when the plate is available at middle of the two plates. Now second case, in that what we have the plate is available at 0.8 centimeter from one of the plane. So one of the plane, so remaining distance, if you find out the y minus 0.8 centimeter, that means 2.4 minus 0.8, it is 1.6 centimeter. So this is a 1.6 centimeter distance from another plane. So we can find out. So similar to previous case, so F1 drag force is equal to tau 1 multiply with area of plate. Okay, so tau 1, so F1 is calculated as tau from the Newton's law of viscosity, mu du by dy multiply with area. So here we will find out first at from the top side. So dy is 1.6 centimeter for first case, and second case it is 0.8 centimeter. Okay, so y1, so we'll substitute the values. F1 mu is equal to 8.10 into 10 raised to minus 1, velocity is 0.6, area is 0.5, divided by dy is 1.6 into 10 raised to minus 3. So force applied from top plane, as we can find out, 110 into 0.6 into 0.5 divided by 1.6 into 10 raised to minus 2. So this is becomes as 15.1875 Newton. So this is the force from top plane. Okay, now similarly we can find out the force from bottom plane. So force from bottom plane. So similarly with previous case, F2 is equal to tau 2 into area of plate. So F2 is equal to tau 2 as mu du divided by dy2 into area of plate. So mu is equal to 8 into 10, 8.10 into 10 raised to minus 1. Dy is, as it is 0.6, and dy2 is 0.8 into 10 raised to minus 2, and area of plate is 0.5. So F2 is equal to If you solve this one, is 30.375 Newton. Okay. And total drag force as F is equal to F1 plus F2. So F1 is 15.1875 plus F2 is 30.375 Newton. So this is equal to 45.5625 Newton. This is again a total drag force. Okay.